Section 11.6 is a section called the Power Theorems, and it's also referred to in a lot of books as the power of a point. There's 3 power theorems that we're going to talk about. I'm going to derive one of them, and then I'm just going to assume that, well, the other derivations are very similar. So we'll start out with a circle. And we'll start out with a chord and a chord. So something like this. We'll label it A, B, C, and D. And I'm going to go ahead and draw in a couple of auxiliary lines here. Let's draw in one here, and let's draw in one here. And let's call this point E down in the middle here. And hopefully what you can see here is, or hopefully if I point this out to you, you can see that this angle right here and this angle are congruent to each other because they are inscribed angles that intercept the same arc right there. And the same thing goes for these 2 angles right here and here, because they also intercept the same arc AD right there. And so because of that, you can see that triangle ABE is similar to triangle, let me make sure I get the letters correct here, to triangle DCE. And so I can write a proportion based off of that as AE is to BE, as ED is to EC. Do a little cross multiplying here, and I can see that it's AE times EC equals BE times ED. And so that is the general pattern for the first power theorem. The first power theorem is a chord-chord power theorem. And I'm just going to give it some letters here. A, C, B, D. Let's call this X down the middle. And the pattern ends up being AX times XB equals CX times XD. And that's going to be the general pattern there. So AX times XB equals CX times XD. 2 other power theorems here are the tangent secant is next. I'm just going to give the pattern to you. Let's call this P, Q, R, S. And so the pattern ends up being PQ squared equals QR times QS. And hopefully you can kind of see it's sort of like sunshine. If I think about it, like if this was a side that the sun is shining on, that's the PQ squared, and then this is the short, and then this is the long shadow. QR is to QS. So that's a tangent secant, and then the next one is a secant secant. So if I draw the secant and a secant like this, X, Y, Z, W, and T. And this is sort of like sunshine also. If I go, it's going to be short shadow times long shadow equals short shadow times long shadow, like that. So it's going to be XZ times Oops, sorry, this is a y. So it's yz times long shadow xz equals wz times tz. And so, again, sort of like sunshine, you want to know the patterns here. Don't memorize the letters. So for this one, it's just going to be chord. It's going to be this times this equals this times this. And then this is going to be the ones that are, these are going to be the ones that are sort of like sunshine. So it's this side squared equals short shadow times long shadow. Short shadow times long shadow equals short shadow times long shadow for the secant. The difference in this section, of course, is that we are dealing only with segment lengths here, as opposed to in the previous sections we had been doing a bunch of angles and arc measures. All right, let's try some problems by flipping over to the back side of this worksheet. All right, let's try some problems on the back side here. Given that this length is 2, this length is 5, wy is 10, which makes this 8, and you're looking for zx. Let's find za first, and then we'll just add 5 to it. So this just becomes 2 times 8 equals 5 times x, and so x is going to be equal to 16/5, and then you would just add 5 to it to get zx. So zx is equal to whatever 16/5 plus 5 is. Letter B, let's give that a try. So AD is 4, BC is 2, and BE is, we'll call it X. If AD is 4, we know this is also 4 here. So I'm going to do the sunshine thing here. The pattern is going to be x squared equals short shadow, which is 2, times a long shadow, which is the entire length, times, what is that? It's going to be 10. Okay, so that means that x is equal to the square root of 20, or x is equal to 2 root 5. And you can just leave it like that. Letter C. Looks like a secant. GH is 6, HJ is 3, KL is 5. We're looking for JK, which is X. So I can just do 3 short shadow times 9, the entire length, short times long, equals X times X plus 5, and I'm not going to see right now that I'm going to end up with a quadratic. This is going to be, what, 27 equals x squared plus 5x. Subtract 27, 0 equals x squared plus 5x minus 27. Factor it. It doesn't factor. I think you have to plug it into the quadratic formula. X ends up being equal to 3.27. Through the magic of a previously done worksheet already. So, answer key. This one here is, this is 2 root 5. NP is 1.5. We're looking for QP. Where's Q? Or yeah, QP is right here. We'll call it X. And what we can do here is we could actually, I would probably make this entire length equal to X. Makes the problem a little bit easier. So it's going to be 2 root 5 squared equals 1.5 times X. I'm going to solve that thing for X, and then we'll subtract 1.55 from it. Okay, so whatever that comes out to. I think the answer ends up being, by the way, 11.83 repeated. Oh, let's see what else we got here. Let's jump down to this guy. So MR is 3, RP is 6, and Q this time is 11. So what we do in these situations, we're looking for the length of QR, so let's call that x, since that's the one length we're looking for. We'll call this 11 minus x. And then I'm just going to do the same thing here. 3 times 6 equals x times 11 minus x. And I'll go ahead and solve that. When you do solve that, you actually get 2 answers. X ends up being equal to 9 or 2 if you solve the quadratic. And the last one here, find the value of x. I know I need to find this guy first right there. So I'm going to call that y. So I'm going to get 8 squared equals 5, short shadow. Long shadow is going to be, well, it's going to be y plus 10. It's 5 plus 5. And then I'm going to solve for y. Y ends up being 2.8. And then you end up with a chord. So it ends up being 5 times 2.8 equals 12 times x. I think x ends up being equal to 7.6. Okay, I think that's it. Hope you understood what we just did there with power theorems. And I'm going to let you go ahead and try some problems from the homework now. All right, take care.